Good morning, this is Ryan Kim from the Overseas Sales Division in iMediSync. Firstly, I would like to thank you all for attending our workshop at ISNR 2021. For today, I would like to go ahead and proudly introduce our products, including iSync, a mapping-based dry-type QEEG measurement device with tunable PBM, and iSync Brain, an AI-driven cloud platform for the early detection of neurological diseases. The total workshop will be 3 hours, including a Q&A session. For the first 90 minutes, we'll demonstrate our products, iSync and iSync Brain. After the product demonstration, we'll proceed with iSync Brain case study presented by John Anderson from Minnesota Neurotraining Institute and Nadia Aristobal from Bright Brain Center for 30 minutes respectively. Then, Dave Kim, our Director of the Technical Support Division, will summarize the workshop by answering general inquiries regarding the workshop. Now, I'll start the workshop by introducing iSync. iSync is an innovative yet advanced brainwaves measurement device with a dry sensor and LED therapeutic functions. At CES 2021, iSync has drawn a significant number of interest from various types of markets, including medical and pharmaceutical industries. iSync is becoming viral from SNS such as Facebook, Instagram, and LinkedIn as well. Even now, we're receiving a lot of feedbacks from the influencers. As you can see from the international news published by the major press all around the globe, iSync is changing the perspective of diagnosing Alzheimer's dementia in an early stage. But you may wonder what is so special about the iSync and drawing so much attention from various kinds of industries. To clarify, I would like to go ahead and mention some of the problems with conventional methods of EEG measurement. As you may know, many patients are having a difficulty in measuring their brain waves with gel-type QEEG devices. When measuring the brain waves with a wet QEEG device, medical professionals must consider the subject's head shapes and sizes to manually select the position of the electrodes in advance. Besides, their subjects must go through cumbersome processes injecting gel to each channel when attaching the electrodes. As a result, these processes directly lead to decreased usability of QEEG measurement and patients' satisfaction. Measuring the brainwaves with a fabric cap type device can also be significantly cumbersome as well. The critical issue with cap type measurement is that it offers weak contact to the subject's scalp and is unable to properly maintain the 10-20 system during the measurement. In addition, it limits the usability for both doctors and patients as it still requires cumbersome processes to manually select the position of electrodes for the measurement. To combat these issues of the conventional method of brainwaves measurement, iSync has entered the market with the answer. Firstly, iSync has 19 channels with internal adjustable gear that automatically adjusts the 10-20 system when wearing the device. With AGA-GCL coated polymer electrodes, it offers better signal quality compared to the conventional electrodes. It's also adapted with analog front end to amplify its signal quality up to 104 times as well. It's convenient to wear even by the elderly and offers excellent contact along with low impedance without complicated processes. With personalized PBN function, ISNR enables medical professionals to create specific light treatments for their patients in accordance with different conditions and diseases. To be more specific, I'll move on to the detailed specification of ISNR. ISNR has 19 EEG channels with one frontal ground channel, and each electrode is adapted with built-in near-infrared LED bulbs supporting pulse rates between 1 to 45 Hz. With a fully charged battery, it offers to measure the brain waves for around 84 subjects consecutively. It's compatible with Type-C USB, and it takes 132 minutes to fully charge the device. An app called iSync Me offers an even easier user experience with Bluetooth function. To clarify, let's have a look at the video clip that demonstrates how to use ISNR. Right, now with this presentation, I would like to explain how ISNR works to measure the brain waves in an easiest way and create an accurate analysis report with collected data. And also with this presentation, we will see how conventional EEG software that consumes significant amount of time to measure and analyze the brainwave data. Now, this is ISNR, designed and manufactured by iMediSync. As you can see, it looks like a tortoise helmet, but there are tons of technologies inside of this helmet. Now, I would like to go ahead and explain what is so special about the helmet ISNR. Firstly, exterior. From the outside, there is a power button and a charging socket. The power button changes its color depending on the status of the battery. It shows red when it is charged under 10%, magenta when it is 10 to 30% charged, and blue when it is 30% to fully charged. It's compatible with Type-C USB and takes approximately 132 minutes to fully charge the helmet. With fully charged battery, you can use the device up to 7 hours. Assuming that it takes around 5 minutes to measure the brainwave for one subject, it allows to continuously measure the brainwaves for approximately 84 subjects. There are 2 earplug sensors connected to the device. With the left sensor, it checks A1 reference, and the other works as a one-channel PPG to measure heart rate during the brainwave measurement. Now, let's go ahead and see what is inside of this smart helmet. To start with, ISNR has 19 channels in total, and one of the key features of ISNR is the adjustable gear, which automatically allows to set 10-20 system when wearing the device. As you know, conventional cap type require different types of cap depending on each subject. But with ISNR, you won't be bothered anymore. Each polymer electrode is ergonomically designed to gently contact subject's scalp when wearing the device, and it also offers great signal quality with AGCL electrodes. In addition, it is adapted with analog front-end amp to amplify its signal up to 104 times and reduce noises to increase the accuracy of the collected data. As you can see from here, this is LED light adapted with 19-channel tunable PBM, which allow to selectively activate the brain function of the subject between 1 to 50 Hz in accordance with specific conditions for each subject. Before wearing the helmet, make sure to remove all of accessories and cleanse your forehead with wet wipe. Make sure that 3 frontal channels are 2 cm above the eyebrow
so that the rest of the channels fully contact the skull probe. Now, let's go ahead and unveil the helmet. Then, attach earplug sensors to both earlobes. Left sensor is for A1 reference, and 1 channel PPG for the right sensor. Now, this tablet PC is included in the iSync Way product package. Software called iSync Me is pre-installed to the tablet to measure the brain wave through iSync Way. Firstly, turn on the tablet and pair iSync Way with iSync Me through Bluetooth. Next, impedance check. It appears red when impedance is high and green when it is low in impedance. One of the alternative features I also would like to explain is the vibration. With vibration function, it automatically lowers the impedance by making contact closer to the spiral. As you can see, red sections are now turning to green through automatic process. Sections which are not turning to green by vibration, adjust or lightly press the sections to avoid direct contact to subject's head. Now, when you are ready for your measurements, tap complete. For 15 seconds respectively, perform an EEG and PPG signal test. Now, once an EEG and PPG tests are done, it begins to measure the brain waves for the subject. It measures 2 minutes and 30 seconds with eyes open and closed, respectively.
If you tap Start Measurement, the brain waves are recorded after 5 seconds. It measures the brain waves with eyes open and closed for 2 minutes and 30 seconds respectively. Once the measurement is completed, collected data is uploaded to iSync Brain Cloud Server for analysis.
Once the analysis is completed from the iSync Brain Cloud Server, you will have a complete analysis report like this.
iSync Way offers an intuitive analysis report with clear infographics including the reviews of a patient's brain, mapping between EEG signals and the source cerebral cortex locations. The color indicated in 3D views shows conditions of the brain with the Z-score criterion. Red indicates excessive power, and blue indicates a less power, and green indicates normal range compared to the normative database of the healthy group. The analysis report also provides information on brain lobe functions. A standardized ratio of theta and beta is used to evaluate the functional decline of the cerebral cortex with a specific percentile between 0 to 100. It also provides scatter plot analysis with a clear infographic to help with early diagnosed mild cognitive impairments. Color circuits indicate each brain lobe, including the frontal, temporal, parietal, and occipital lobe. The more the circuits are near the contour, the bigger the probability a patient has healthier brain functions. If the circuits are near the red box indicated at the right side of the bottom, it indicates that the patients are likely to have MCI. Now, Dave Kim, the Director of the Technical Support Division, will continue and introduce an AI-driven cloud platform, iSync Brain.